Good afternoon, everybody. We just want to wait for a few more minutes for some more attendees to come on. We have a good presentation lined up for you here, and hope you can wait for a few more minutes. Okay, let's get started. Good afternoon, everybody, and thank you for attending this the third of our FY20 series of Spatial IQ User Group Educational Webinar series for this fiscal year. We've been developing and hosting these webinars on topics that would be of interest to local governments with the aim of increasing your spatial IQ. Thank you very much for being here today. We know it's a stressful time for everybody, and we hope that this distracts you a little bit and also you get something out of it. Today we will discuss the MS4 Municipal Separate Storm Sewer System Permit Mapping requirements and how we've helped communities comply. You'll learn about the MS4 mapping requirements in Connecticut, Massachusetts, and Rhode Island, and hear about some case studies highlighting data conversion, outfall field mapping, resolving disconnections in the data, and some DCIA analysis as well. With you today is Rebecca, who's a project manager and member of our Spatial IQ team. She's been with the company for 5 years, focusing on local governments. Rebecca has extensive experience with mapping utility systems, primarily stormwater systems, and as well as field collection. She's assisting several municipalities with their storm data development maintenance for the MS4 permit, and she'll be sort of doing most of the presentation today. Many of you know Michelle. She's a senior project manager at AppGeo and the Spatial IQ program manager. Michelle has 19 years of experience in the GIS field with extensive experience in project management, analysis, utility data, and many other projects. Michelle is currently managing a large utility data conversion project for Rutgers University and has managed and provided expertise on some of the municipal stormwater mapping projects that Rebecca will be discussing with us today. And I'm Priya, project manager here at AppGeo and a member of the Spatial IQ team. I've been with AppGeo for over 10 years, managing a wide variety of projects from data and application development to analytics and focusing on local governments. Just to cover some logistics with you, currently you are all in listen-only mode. If you have any questions during the presentation, please feel free to put them in the questions box in the control panel. You'll find it in the GoToWebinar control panel that has it's a questions box, and you can submit the questions there. We'll monitor them as we go and answer them at the end of the webinar. And we hope to get through all of the questions, but if we don't, we'll make sure we'll send you a follow-up email with answers to all the questions. The webinar is, of course, being recorded, and we will share it along with the slide deck for you to share or review. And now I'm going to hand it over to Michelle to take it over from here.
Hi, thanks, Priya. So I'm going to just talk a little bit about the MS4 permit in general, just to orient ourselves before we get into the real fun stuff. So the EPA's National Pollutant Discharge Elimination System, NPDES, they had phase 1 stormwater program, which was initiated in 1990 and required operators of medium and large municipal separate storm sewer systems, the MS4s, specifically those that serve a population of 100,000 or greater, to obtain permits and implement a stormwater management program. And this was as a means to control polluted discharges. In 1999, NPDES stormwater program was expanded. They started a phase 2, and that required operators of small MS4s to obtain permits and establish a stormwater management program that's intended to improve the water bodies by reducing the quantity of pollutants that can enter the storm sewer systems during storm events. Small MS4s include the MS4s that are serving populations of less than 100,000 people, and those that are located within urbanized areas as defined by the census. So the states adopted these phase 2 rules and then issued general permit requirements for the MS4s to follow. So what's going on around here in our neck of the woods in Connecticut, Mass, and Rhode Island? I'm going to focus a little bit more on the details for these three states. So starting with Connecticut, a bit about the timelines of these permits. Starting with Connecticut, DEEP first issued its first general permit requirements in 2004, which covered 113 municipalities. And then in 2017, they issued a new permit that applied to all the existing 113 MS4 towns, but it also added in 8 new towns and all state and federal institutions that operate a stormwater system. The MS4s are required to submit an annual report to DEEP indicating the progress with implementing their stormwater management plan. And the Connecticut permit expires in June 30th of 2022. In Massachusetts, May 2003 is when EPA Region 1 issued its final general permit for stormwater discharges from small MS4s that covers the traditional and non-traditional MS4 operators. So traditional would be like cities and towns, and non-traditional would be federal and state agencies. That permit expired on May 1st, 2008, but remained in effect for authorized operators until they were authorized under the 2016 MS4 final general permit. Municipalities were required to submit an annual report to EPA and Mass DEP each year of the permit term. And they also had to submit those annual reports, which included a self-evaluation of their effectiveness of their program and describe their compliance with all the applicable permit terms and their progress in addressing their stormwater pollution. And in Rhode Island, in December 2003, the Rhode Island Pollutant Discharge Elimination System, the RIPDES program, issued the first general permit for the stormwater discharge from small MS4s and from industrial activity at eligible facilities regulated by small MS4s. So under their general permit, MS4s were required to submit an annual report that documented the progress made toward achieving those requirements of the program, and also reporting on the ongoing maintenance of their stormwater system. Rhode Island MS4s were also required to identify and locate and map all their outfalls for their stormwater system that discharge to the waters of the state. And Rhode Island DEM has taken the data that's been provided by the MS4s and created a GIS layer with the outfall information that's actually available on ArcGIS Online. So a little bit about the specific mapping requirements of these three states. They're very similar across the states, but I'm just going to highlight some of the differences. Connecticut and Rhode Island both require detailed mapping of the entire stormwater system, whereas Rhode Island only required detailed mapping for portions of the system that are associated with investigation and tracing of illicit discharge. So you find illicit discharge, you want to trace it, you want to investigate it, you got to map out that portion of the system in detail. In Rhode Island, outfalls had to be GPSed or surveyed, whereas in Connecticut and Massachusetts, they didn't really specify that, a specific accuracy requirement, but they said, outfalls had to be located. And, but, in my opinion, it makes sense to do the GPS regardless, because you're going to have to visit the outfalls anyways to validate that they actually are there and exist. Probably get a photo would be a good idea too, and to check the condition of them. So you might as well have a GPS with you and get an accurate location and then bring that into your data anyways. Mass and Connecticut both required that interconnections be identified, and Rebecca's going to talk to us more about interconnections, and that's an activity that you can do with the GIS. All three required that the names of the receiving water bodies be identified for all the outfalls. So where does the outfall drain to? What water body does it go to? That had to be identified for each outfall. And Connecticut also requires that the water quality classification and a DCIA analysis for outfalls is performed. And DCIA, again, Rebecca's going to talk more about that, but that's the directly connected impervious area. And you can use GIS to assist with that analysis as well. So all three states require the IDDE, the illicit discharge detection and elimination, programs, and this mapping information can obviously serve as a planning tool to support that effort. So since Connecticut still has these active permit deadlines happening, we're going to focus in on Connecticut right now. This coming July 1st, 2020, the MS4s need to have their detailed mapping of the entire stormwater network. And they need to have calculated a town-wide baseline DCIA. Next July 2021, monitoring of the 6 worst outfalls that discharge to impaired waters should be happening. And then by the following July 1st, 2022, inspections of all the catch basins, including those that are outside priority areas, need to be underway. And MS4 should be meeting their goal of reducing impervious connection by 2%. And screening of all the outfalls that discharge to impaired waters should be happening. So there's still quite a bit to do in Connecticut, but we've got a couple of years here to finish it up. So that's just some really high-level introduction to the permit and to the mapping requirements to frame the use cases and the descriptions that Rebecca's going to talk about. But if you're interested in getting more details about the permits themselves, or how to perform the mapping requirements or anything like that, there are a lot of good resources available online from all 3 states. And like Priya said, we'll be sharing out the slides, so you'll have these as well, or you can write them down and take a screenshot. And now I'm going to hand it over to Rebecca to talk about the mapping methods and examples.
Hi, everybody. Thanks, Michelle, for that introduction of what MS4 actually is. So I will be talking about kind of 4 general methods that we have to mapping an MS4 compliant detailed stormwater GIS system. The first main step is obviously to create the data and develop it, which I'm going to be highlighting a couple of key methods that we have been using for several of our clients. Also, while we've been doing the development, we are also identifying any issues that we find. For example, if a source file is missing, or if the source file is showing us one thing but the imagery is showing us another, we identify those locations to later resolve those. So that way we have a complete system. And then we are also going to be running some calculations that Michelle had briefly mentioned of getting the water body and drainage analysis and DCIA analysis complete for the permit for compliance. And then lastly, I'll also be talking about the interconnections for the municipal system. So our first method we have is converting from AutoCAD to GIS. In this case here, the town was maintaining their stormwater data for about 15 to 20 years in AutoCAD, and gave this as a place to start. The quality of the CAD was not the best, as you can see. There was some placement and scaling that didn't really match up to what we had in GIS for their parcel data and for the imagery. So we really just kind of used the CAD data as a reference. So we placed the catch basins and visible features on the ortho as best we could, and then we kind of made the connections of the drain lines and just used that as a reference. And then, of course, we attributed any of the pipes that had sizes, dimensions, material, anything like that. We're populating that as well. So one benefit to the CAD conversion that it is a little bit quicker, and depending on the quality of the CAD, it can be a very automated process. But again, if the quality of the CAD is not the best in terms of placement, then it's going to be a little bit more difficult and require some more manual work. But it's still a little bit quicker than some of the other methods that I will be talking about. But some disadvantages to using the CAD is that you clearly don't get as many details as you do in say a survey. So while there's advantages, there's also going to be disadvantages for each of the scenarios that I'm going to be talking about. So the next method is digitizing, georeferencing and digitizing from as-builts. For this method, the town had gone into their basically their history of records from any subdivisions, any road construction, anything that had happened in town in terms of road maintenance that had to do with their drainage system. They provided that to us, pulling the most recent plans first and then working their way back to some of the older plans. So we had geo-referenced their files if we couldn't see things on the imagery. And then depending on if the client is requesting the geo-reference files or not, it can take a little bit more time to do that process. But if you're kind of just using it as a filler and using the imagery, it does go a little bit quicker. One advantage to using the surveys is that you get a lot more information. As you can see from the screenshot here, you're getting for example, the catch basin number, what the top of the rim elevation is, and where the bottom of the catch basin is for where the flow is in terms of elevation. So we capture all of that in our data. We have a general schema that we use for clients, and certainly we tailor it to the client's needs. So if it's there, we absolutely capture it. But one disadvantage to having all of this information is that it does take time to populate, but your quality of the data is much higher. And with any of the source files that we use and get from different towns, we hyperlink and we can associate all the attributes to whatever source that was used. So down the road, if you wanted to go in and hyperlink this to a different data viewer or anything, you could link that and pull up the plan super easy instead of trying to go back into the filing cabinet to find this plan. So the next method is field data collection. For this method, you'll kind of need to know what areas still need connections added and features captured. So you can either determine this by looking at the imagery and seeing that there's catch basins along a road, but they're not in the provided CAD data, or there's no as-built for it. So you want to identify those areas to go out into the field and capture. For this particular scenario, we use the ArcGIS collector application. We just had it on a tablet. We loaded in the existing data that we had in case something connected along the roadway, but for this, we were in a cemetery. Everything was confined to that cemetery. So as you can see, we have green points, which we had as just field editing points that we added for catch basins. And then the two in the woods to the north that are for the outfalls, we kind of estimated those locations. There was a fence behind the cemetery that we couldn't get to, so we kind of just estimated those and then marked those for another day in the field to go verify those. One of the benefits to going out in the field, besides the fact that it's fun and awesome, is that you get a more accurate location of where the features are. Like Michelle was talking about for the outfalls, is that if you're going out there, you might as well GPS it and get that accurate coordinate location. But one of the disadvantages to going out in the field is that it is very time consuming. But again, you kind of get that higher level of accuracy. But then again, you also don't get all of the attribution. You can get the elevations at the top, but you can't necessarily get the elevations down within the catch basin. Sometimes the catch basins are full of sediment or water and you cannot see in them to see where the connection's going. So at that point, you would kind of need to get the town involved to pop the cover off, dig it out, empty it, and then go back out into the field to figure out what was actually going on at that location. So next we have our Outfall Inventory. This method is not one that's going to be done first. This is going to be done towards the end once you have a pretty good baseline of the data so you know where you're going to find these outfalls. So some things that we've learned since going out in the field from day one to now was that we created a roadmap that basically kind of outlined what we were going to be doing that day. I was leading the outfall inspection, so what I did was I would have all my list of outfalls that needed to be verified, and I would basically get the nearest address to how we would access that outfall, and kind of just create a spreadsheet. So when we're out in the field, we can just put in the address into a GPS and say, all right, let's go here. And then you just go down the list. So you kind of keep things in order. You're in the same area, you're in the same neighborhood, because you don't want to be out in the field and be like, okay, what's the plan? You need to have that laid out ahead of time. So for what we were doing out in the field was, as you can see, we were verifying each outfall that, one, it existed, two, we were validating the size of the outfall itself, what material it was, and we were taking a picture of the outfall. So some other lessons learned from this field inventory was that make sure all of your tools are charged, all of your GPSs, all of your tablets and things like that. Your camera has batteries. Definitely don't want to have a day where you miss a charge. And then the other thing that you might notice in this picture is that we have a clipboard that has a chalkboard to it. We have the name of the outfall written on there. Originally, when we started doing this project, we were using a small whiteboard, and we found that using that, you get reflections from the sun, reflections from the water, and you couldn't read what was written on it. So we went to the chalk method, and it worked so much better. So those are just a couple of lessons learned that we've had from being out in the field. So changing topics, we're going to look at identifying and resolving issues that we find while we're doing the data development, and potentially later on once we realize something was missed in the data. So in this screenshot, we were working with a town that kind of had areas where they didn't have any data, but we could see things on the imagery. So we captured what we call verification areas, which I think you can see it enough. It's like that yellow little polka dot polygon. Those are our verification areas. And we provided the town with field maps that basically were their tax map index. So we printed out all of their tax maps showing all of their stormwater, and also showing these verification areas for where more investigation needed to be done to either answer a small, simple question asking if a catch basin connects to anything or if it's just a dry well, or in this case where we could see many catch basins along a road, assuming that there would be an outfall somewhere to be located. So the town would then provide us back either their spreadsheet with resolutions, or they would provide us back their actual map books and show us all like the sketched up areas that they had been to. So we would take that back, put it into the data and clean everything up. And if another round of verification areas need to be done, we would do that. So verification areas are kind of for a larger area. And then we also have errata points that we use for small individual features typically. In this particular case, we had a question where the green star is under like that circle, which we have as a manhole. We couldn't see the manhole on the imagery, so we had flagged it from the CAD conversion. And then we had the town go out into the field to verify if that was actually accurate, if the manhole had been potentially paved over, if there was some road work that had recently been done, or if it doesn't exist there. So on the right, you can see their sketch of what they found in the field was that we had the manhole in the wrong location. The manhole was actually more towards the grass and towards where that driveway is. So we then took their sketch up back and brought it into the data to clean it up. Another way to do errata resolutions and verification area resolutions is to also use the field collection method. You can take out the tablet into the field using the collector app again and loading up in the data, getting the errata points or verification areas into the data and updating it directly while you're out in the field. So you can add in your lines, add in your catch basins for anything that's missing, or add in any notes that you can then process back into the office. So next, we're going to talk about some of the drainage analysis that need to be done to comply with the MS4. So the first one that I'm going to be talking about is the drainage analysis for the water body watershed classification analysis. So in order to determine where your outfall is discharging to, AppGeo has created a script using Spatial Analyst to do exactly that. So in the screenshot here, you can see that we have blue dots as well as some pink lines. The dots are the outfalls, and then the pink lines are the shortest path to the water body from the outfall. So our script does all of that. Basically, the data that you need in order to run our script is the outfall points, the hydrography, which is your streams, your water body, and your watershed, which can come from the state's data if you don't have it for your particular town. You need a LiDAR or DEM terrain model, and then the state wetland soil data. Basically, the script takes all that data in, it does its thing, and then it spits out an output of the outfalls with these fields populated for the water body name, ID, the water quality class, and then the watershed with the associated subregion basin number, which all of those things are coming from the state's original data set. And then the second analysis is the catchment delineation and DCIA analysis. So just before we kind of jump into what it's all about, I just wanted to kind of run over some terminology. So for those who don't know, a catchment area refers to the land from which the stormwater runoff is collected and discharges through an outfall to surface water. And then DCIA, which is the directly connected impervious area, is the impervious area from which stormwater runoff discharges directly to water of the state or directly to a stormwater sewer system that discharges into waters of the state. And it's good to note too that for the impervious areas that discharge through a system designed to retain the appropriate proportion of water quality volume are not considered in the DCIA. So AppGeo works with an engineering company that does the catchment delineation, looking at where the flow is going from the streets to the catch basins all the way down to the outfall. So they will provide us back a polygon with that information, with the boundary of the catchment as well as the outfall that it's associated with. They also provide the connectivity level and the values through 1 through 5, which you can see at the left, which came from the Connecticut NEMO site. And then based on those connectivity levels, we then run the calculations on the outfall to determine what the DCIA is for each of those outfalls. Now, the goal of the permit is to have the DCIA of any catchment below 11%. For anything that's over that 11%, should be reviewed further to see if you can reduce that number at all. And to do this, you would want to look to see if anything has been disconnected, if there's been a detention or retention basin added, if anybody has a rain garden separating their house from the actual system, and to see if there's anything else that could potentially be disconnecting the system. And then for the catchments that are within urbanized areas, as well as anything that directly connects to the impaired water bodies and has a DCIA greater than 11%, are all considered priority areas. And those are subject to the stormwater monitoring and other activities focused under the MS4 permit. And then lastly, we have the interconnections. Again, quick terminology is that an interconnection is a point where the town's MS4 discharges to another MS4 or other storm sewer system through which the discharge is conveyed to waters of the state or another storm sewer system that eventually empties to water of the state. So also a quick legend for what you're looking at. The red lines and features are town owned, the purple is private, and then the state is blue. So here you can see that we have interconnections in 3 locations. We have the 2 purple catch basins from the private businesses discharging into the town's system. And just a quick attribution, we identify who owns it, which all of the interconnections that we capture are considered town-owned. And then we also identify what the feature is that it's connecting to. So in this case, in all three of these cases, they're connecting to catch basins. For the flow, for both of the privates, they're coming into the town system, and they're both private to the town. So we also have that ownership change identified as well. And then similarly for the town system connecting to the state system, the attribute difference there would be that the flow direction would be outgoing, so that it's leaving the town system and then it's entering into that state system. So we capture these as we develop the data, and we're confident in the ownership. But if we're not confident in who owns that particular part of a system, we'll want to verify that with the town, and they'll want to verify that potentially with the owners and verify that everything is correct there, and then we will add in those interconnections afterwards. So they can be done while you're doing the development or afterwards to make sure you have all of your ownership information correct. So that covers all of the requirements that the MS4 permit has, but there's still plenty more ways that you can enhance your data to make it even better. So I'm going to talk about a couple other ways to maintain and build out your your stormwater data. First, we have drainage easements. Depending on the sources that are provided to us, easements are identified. We haven't seen too many easements on the CAD files, but on a lot of different maps and as-built and surveys, we've captured plenty of easements from there. So that's one way to do it. And the easements are the green hatched area. In this case, you can see that the town system is passing over the private ownership of those lots, and that easement allows them to access and maintain their system. So we capture those as we see them as we're going along. But also, after the fact of everything, we also have kind of run a selection to identify those drain lines and features that are on private property that do not have an easement, and then we provided those to the town to look into it more. So they would go in and look at old deeds, look at old surveys to see if anything was missed, because potentially this data could have come from, say, a CAD file, and the CAD file didn't have any easements, but there's a survey that exists that does, and we were just never given it. So the town is now going through and pulling out all these old surveys that were never given to us for us to then capture those easements so they can build out their system even more and make it even better. And lastly, now that your system has been built, you want to keep it up to date and maintain it going forward. So there's kind of two ways of doing this. The first way is that if you don't want to have kind of any part of it, AppGeo is can certainly do the updates and keep that data maintained for you as long as you provide us with that information. So anytime there's a subdivision or any work that's done to any of the catch basins that currently exist, if there's new pipes put in, anything like that, we would pass it to AppGeo and we would take care of that through your support budget, or if there's a particular project to bill it to. We would take care of that. And then the other option is to have you, the town, maintain your data going forward once it's been developed. So one way of doing that is, again, using the collector app. In this particular case, the town is going to all of their outfalls and capturing any missing attribution that they might not have had from the source file. So they can capture the diameter, they can capture the material, they can capture the type of outlet structure that's on the outfall. So if it's a flared end, if there's a head wall, if there's any riprap or anything like that, they can identify it and put it directly into their data through the collector app. And then another thing that some people have used is the collector app or other applications similar to it to do their street sweeping in conjunction with their catch basin cleaning. So as you're going down doing street sweeping and you're cleaning out catch basins at the same time, they can go into the data and mark off a catch basin as, yep, completed on this date, emptied this much sediment or debris, from this catch basin and continue going on. So they can do that in the field with conjunction with other projects that might not necessarily be stormwater related. So some MS4s require public engagement education on stormwater and stormwater runoff. So one of those ways to help make your town comply with that part of the permit is to have your data available to the public. What's the solution? AppGeo. I'm sure most of you are all aware of AppGeo, but it's your public viewer that AppGeo hosts. And we have several towns that we have that host their stormwater data on here, and they can check off that little checkbox within their annual report to say, yep, we have educated the public and it's available to them to see and to look at anytime that they would like. So in the beginning, when I was talking about the as-built, I had mentioned kind of hyperlinking, and this is where that comes into play. So in the left image, you can see that the little pop-up is above one of the line features. So if you click on a line, you'll get a link to a plan. So you can just pull up that plan right on your phone, right on your tablet, or from your desk while you're working and say, where did the stormwater come from? And you can pull up that plan and see right where it came from. So that makes it super convenient. And then an example that's on the right side is we have a similar pop-up over on an outfall to tell you the outfall ID, size, material, but then you also have a link to the photo during the outfall inspections that took place. So you can see what it looks like. You can see if there's any issues, any maintenance notes that needs to be taken care of in that image as well. And lastly, some folks have asked us for maps to put into their annual report, or to have at any events that they're having that kind of also check off that education checkbox. So these are just maps that are similarly showing the same thing. Basically, it's showing the town's entire stormwater system and what drainage basin that it all falls into. So those are just a couple of examples that we've done for other people. So thank you. That was a lot. I hope you all learned something from that. We will now open it up for questions. So if there are any questions, please put them into that chat box on the control panel of the webinar link, and we will answer them.
Thanks, Rebecca. That was really great. We do have a few questions, and definitely feel free to enter some more questions in the questions box if you have them. So the first question that we have, let's see. We haven't done this yet. What's the best way to get started? So, Rebecca, you want to take a stab at that one?
Sure. So it's really all going to depend on what you currently have, if you have been maintaining your data in CAD, or what you actually have for source information. If you remember, we could discuss a couple of various options to develop your stormwater, such as converting from CAD, digitizing from as-built, doing the fields and survey the field and imagery collection. And I know that there are some towns that might have a spreadsheet of where their outfalls are with coordinates, so we can go off of that as a start as well, and then build the system backwards. Or if they have addresses, we can work off of that. And then field verify whatever is missing from there. So you have a couple of options on where to go, depending on what you have.
Okay. The second question is, I have stormwater data, but I'm not sure if it's complete or accurate. What do you suggest?
I would suggest looking at whatever the most recent construction that has taken place in town, or any development, to determine anything that's new. So if you have been maintaining your data at all, you can go off of that if you have an idea of when it might have come from. So if you know your data was potentially last updated back in 2009, you'd want to look back at your permitting system or whatever you do to kind of keep track of all of that to start pulling anything that was 2009 to now, and then compare that to the GIS for what you currently have and check the accuracy on that one. Another way to do that and compare your data is to check the recent imagery. For Connecticut, we have 2019 imagery available to us, so you can check the imagery to see if there's new catch basins that have been added or if something is missing from the original data that you had. So you have that to do. And again, there's the field verification with the map and grade GPS to confirm features that you can see, such as the outfalls, the catch basins, and any manholes, and then use that GPS data to adjust the network for your current data. So you have a couple options.
Yeah. All right. Let's see. When inventorying the outfalls, what did you do if you couldn't find the outfall or if you weren't able to get close enough to it?
Great question. So for outfalls that we could not locate because they weren't visible, we couldn't find them, or whatever the case was, we would go back to the last catch basin where we think that the outfall is leading off of. And if there was no line in there leading to that outfall, it clearly doesn't exist there. So we would kind of do a little bit of investigation while we're out in the field to kind of work our way into this, back into the system, to see if we have it coming off of the wrong catch basin, or what the issue is. If we couldn't figure that out while we were out in the field, we would make note of that and send it to the town for them to do an investigation and or pull a survey if something has been redone. So that's kind of that part of it. If we were unable to access it because it was either in a culvert or if it was behind a fence, we would make a note of it. If we could see it, if we walked down like the side near a stream where the culvert was, if we could see a pipe coming out of it, we'd kind of just say, yep, something exists there, that's okay. But then if we truly couldn't get to it because of a fence, in a particular case that we had, we let the town know, and they were like, oh, we have an easement there, so we have a key to that fence, so that we had gone with the town, they had let us in, we went to go find the outfall, and we were good. But in other cases, that doesn't happen. So we had just made a note of them, provided those to the town so the town's aware of them, and basically left it up to them to verify those when they could.
All right, great, thank you. Let's see, we've got another question here. Do you use imagery to identify impervious surfaces? I can help you on that one.
So yes, we can and we do. In some cases, I'll speak to Connecticut at least. For the permit for Connecticut, they were using the 2012 impervious cover layer that was created during a flyover. So that was kind of the baseline that was used. But if a town maintained and took care of their driveways, sidewalks, buildings, roads, parking lots, anything like that that was impervious, and we had that data, we would use that more updated data to get a better accurate number when calculating their DCIA.
Right, and some towns do their own flyovers and then capture a planimetric data set, and like, for instance, in the West Hartford case, that's what we used, is their planimetric data set that they got from the MDC, and that we maintain each year as we get other data updates. We digitize and update those features from those sources as well. So theirs was really detailed, and so their numbers were like really detailed, as opposed to using the generalized 2012 layer from the state.
Yes.
All right, let's see. We got a couple more questions here. What types of interconnections would you recommend focusing on first, if any?
So it's kind of going to depend on what you have in your data currently and what's available on source files. I'll speak to the interconnection example that I had showed. The data that we had gotten, that all came from, they had old topographic maps from like 1985 that we had captured. And we were able to identify that this is a state road, so this has to be all a state system. And then we kind of made all the obvious assumptions in terms of ownership and then made our interconnections that way. So I don't know if there's a particular first thing to look at, other than just kind of getting started.
Yeah, because I can imagine that with GIS, we can kind of automate a lot of it too and say, find catch basins or find manholes where they intersect with mains of ownership, state and municipal, and like narrow down our focus and then go and look at each one in a systematic way. All right, so let's see, got a couple other questions. A really important question, Rebecca. Have you ever fallen into an outfall?
I have never fallen into an outfall, no, but there's probably some fun stories that I could tell about being near outfalls.
Okay, I think that covers all the questions, and I will review them again afterwards and send out an email if we didn't end up answering anyone, if I happen to miss one. But thank you all so very much for your participation and joining us today and your time and attention. This has been great. We'll leave you with some last thoughts here. Based on this, have you met the MS4 mapping requirements for your state? And if you have, is your data up on your AppGeo site yet? With either of those, we can help you. We're here to answer your questions, to brainstorm ideas with you, and to help solve any problems, and ultimately to raise your spatial IQ. And so definitely reach out to us at our spatial IQ support email address if you want to talk more. Thank you all so much, and have a wonderful day.